Okay students, so in this numerical we have been given an electron and a photon, and both of them are having same wavelength. Photon is a particle of light. Okay, so the light of which photon is a particle is having wavelength 1 nanometer, and the wave which is associated with this electron is also having wavelength 1 nanometer. Now we are supposed to calculate momentum of electron and photon. So the formula for momentum of a photon is P is equals to h upon lambda, and the momentum of electron also can be given by same formula as the wavelength which is associated with this electron is similar to that of photon. So we'll substitute the value here. Planck's constant is 6.63 into 10 raised to minus 34 divided by this wavelength here is given in nanometer, so we'll convert it into meter. So 1 nanometer is equals to 10 raised to minus 9 meter. So I'll have 1 into 10 raised to minus 9 meter. And when you solve this, you'll obtain the answer as 6.63 into 10 raised to minus 25. And as this is momentum, the unit of momentum is kg meter per second. So if I want to calculate the momentum of electron or the momentum of photon, I'll be using the same formulas and same values. So momentum of electron will be equal to momentum of photon. Now in second portion, we have to calculate energy of photon. We know the formula of energy of photon is equals to HF. This frequency is c by lambda. So h c by lambda, this formula we have obtained from the formula of velocity. Speed of light, suppose, is displacement divided by time. Then if I consider the displacement as one wavelength, then the time taken by the light to cover distance equal to its wavelength is given by periodic time, and 1 upon periodic time is frequency. So I can write lambda into f. So from this equation, I have obtained f is equals to c by lambda. Now here I'll substitute all the values. Value of Planck's constant is 6.63 into 10 raised to minus 34. Speed of light in vacuum, c, is 3 into 10 raised to 8. And wavelength is already given. It is 1 into 10 raised to minus 9. So if I solve this, I'll obtain the answer, and it is 19.89 into 10 raised to minus 17. And it is energy, so its unit will be joule. As we are using Planck's constant here, the value of Planck's constant is in joule, right? So this answer will be in joule. Now suppose if I want to convert it into EV, then what I have to do is I have to divide this value by 1.6 into 10 raised to minus 19. So 19.89 into 10 raised to minus 17 divided by 1.6 into 10 raised to minus 19. So this will get converted into EV. And the answer is 1.24 into 10 raised to 3 EV. In the third part, we have to calculate kinetic energy of electron. Now see, we know the formula of kinetic energy. It is half mv square. We know the mass of electron, but we don't have here velocity of electron. But yes, we have momentum of electron, which we have calculated here. So we need to find out the relation between kinetic energy and momentum. And that relation is, we can obtain it from this. See here, what I can do is just multiply by 1m and divide by m. So this will give me p square by 2m. So kinetic energy is equals to p square by 2m. And I'll be using this equation. I have the value of momentum of electron. It was this, and I will divide it by 2 multiplied by m. So momentum is 6.63 into 10 raised to minus 25 divided by 2 multiplied by mass of electron, and mass of electron is 9.1 into 10 raised to minus 31, which you have to remember. If you solve this, you will get the answer as 2.42 into 10 raised to minus 19 joule. And again, if you want to convert this value into EV, then you have to divide this value by 1.6 into 10 raised to minus 19. So 2.42 into 10 raised to minus 19 divided by 1.6 into 10 raised to minus 19. This will give me 1.51 EV. So this is your answer of kinetic energy in EV, and this is the answer in joule.